Welcome to the UML. UML stands for Unified Modeling Language, and it represents the standard modeling language for system design. Now, what does that mean? Well, UML is a visual language that lets you model processes, software, and systems. Up in the corner there, you can see a sample UML diagram. This is an example of a class diagram, and we'll be working with those in quite some detail. What is the UML? UML is made up of notation and diagrams. Those are what we'll be working with throughout this course. By notation, I mean the elements that work together in a diagram, such as symbols, for example classifiers or stick figures, connectors, such as arrows, dependencies, associations, notes that you might add, values, even things like pseudocode and code. All of these things are considered notation. And diagrams, of course, are pictorial elements of a process, a system, or some part of the system, such as the class diagram you saw on the previous slide. Where does the UML come from? Well, it's defined as a set of specifications created and distributed by the Object Management Group, the OMG. UML is defined in two parts, infrastructure and superstructure, and two associated specifications, diagram interchange and object constraint language. You can download these specifications if you want to look them over at the Object Management Group's website, www.omg.org. The UML is extensible. It's the industry standard modeling language, and as just mentioned, the OMG provides the specification that offers the formal definition of UML. But UML is designed to be flexible. Flexibility is one of its great strengths. You can extend it, for example, by using stereotypes, and you can interpret it to meet your own specific needs. While UML's formal definition means that everyone's on the same page about basic notation and semantics, you have the freedom to extend that notation to describe your own particular situation. And it's also worth noting that the UML is scalable. You can use UML equally well to model a huge multi-million-dollar system, or you can use it to do a quick sketch of a business process. It can be as big or as small as you need it to be. That kind of flexibility lets you use UML for a number of different things. You can use UML to model business processes, show application structure, describe system architecture, capture system behavior, and model data structure. And the way in which you use UML can vary as well. You can use UML to sketch out ideas. It's great for tossing around ideas and concepts and drawing them and refining them on a whiteboard, for example. You can use it to build a formal, detailed specification of the system. And you can use UML to generate programming code. You can go directly from a UML model to executable code. In this course, we'll be covering 10 different kinds of UML diagrams. Let me just give you a quick rundown of what those will be. This course covers use case diagrams. Use case diagrams show what the system does from the perspective of actors that play various roles in interacting with the system. We'll look at class diagrams. These define classes and their static relationships. Class diagrams show the kinds of objects in the system and their associations with each other. We'll cover object diagrams. These show the system structure at a specific moment in time. So object diagrams model instances of classes in various configurations. We'll look at package diagrams. Package diagrams bundle elements together to create a higher level view of the system. Also, we'll look at state diagrams, which show a dynamic view of the system's behavior. Activity diagrams also give a dynamic view of the system. These diagrams model workflow, business processes, or procedural logic. We'll look at sequence diagrams, which are a kind of interaction diagram. These diagrams show how objects communicate with an emphasis on time and the ordering of messages. Another kind of interaction diagram that we'll look at is a communication diagram. Communication diagrams also show how objects communicate. These diagrams have an emphasis on links among the objects. We'll cover component diagrams. This kind of diagram gives a view of the system in terms of its components, the modules that represent a system's building blocks. And finally, we'll look at deployment diagrams. Deployment diagrams map software artifacts to hardware to show the system's physical layout. There are other kinds of UML diagrams, but due to time constraints, these 10 common diagrams are the ones that we'll be covering in this course. So let's get started. Because the UML evolved from object-oriented system design, we'll begin with a quick review of object orientation concepts.